Hi there. Today we're on lesson 1.7, and that's entitled Representing Functions as Graphs. And I think you're going to be happy with me today. This video is actually going to be very short. We actually started covering how to write a function as a graph in section 1.6. I had a worksheet that you did where you had to fill out a table. And on that table, you saw a few different categories. You saw verbal rule, equation, table with range of domain, and then I made you draw a graph. And that's kind of where we're at here today, is just making sure we know how to draw a graph of a function. So I think the easiest thing actually to do is just to go and do a homework problem or two with you and make sure that that's something that you do understand how to do, okay? So let's go to page 46 in your book, and let's go to question number 3. And question number 3 says that they want us to graph the function y equals x plus 3. So let's start there. Y equals x plus 3. And they gave us a domain of 0, 1, 2, 3, 4, and 5. So what I'm going to do real quick here is I'm going to make a little table. Remember, x is my domain, y is my range. My domain in this problem is 0, 1, 2, 3, 4, 5. That is my domain. Now remember, a function works like a little computer box. And for this particular problem, here's what the computer box would do. If I input 0 in the box will take 0, it will add 3 to it. 0 plus 3 is 3, and it's going to spit out 3. So, and when it spits out 3, remember, that's not really what it's called. That's called the range, okay? So if my domain is 0, or if my input is 0, this function will output or give me a range of 3. If we input 1 into our function, 1 plus 3 is 4. So if we input 1, this function outputs 4. If we input 2, 2 plus 3 is 5. So inputting 2 would output 5. If we input 3, 3 plus 3 is 6. If we input 4, 4 plus 3 is 7. And if we input 5, the function will output 8 because 5 plus 3 is 8. Okay, so we already have done that in section 1.6. What we're emphasizing today is the graphing aspect of this, so I need to graph this table. That's pretty easy. Remember, we have, whenever we have graph paper, actually this is called a Cartesian coordinate system. You'll need graph paper for this when you come in tomorrow, and I'll have some pre-made up for you, which will make things simple. To graph the point 0, 3, remember, 0, 3 means we start at the origin. This is called the origin. 0, 3 means 0. Don't go left or right. 3 means move up 3, so the point 0, 3 is right here. 1, 4. We'll start at the origin. 1 means go 1 right. The 4 means go 4 up. So I'm going 1 right and 4 up. And then 2, 5 would mean 2 right and 5 up. 3, 6 means 3 right, 6 up. 4, 7, start at the origin, go 4 right, 7 up. And 5, 8 means go 5 right, 8 up. Now one mistake, I'm going to stop here. This is the correct way to graph this. One mistake that I see my students make, and I'll do this in red because this is indeed incorrect if you were to do this, I will see my students then, they will take a ruler out and they will draw a line through these points like this. Now I'm doing this in red, as you notice, because this is totally wrong. If I were to do this, this is indeed incorrect. Okay, I should not do this. That's why I'm putting it in red. It's wrong. Okay, because if you draw a line through it, that means, for example, I can take this point right here and say, oh, well, this point belongs as part of my domain and range. Let's look at what this point is. It's 5 left, 2 down. This is the point negative 5, negative 2. Well, let's check. Is negative 5 part of my domain? And the answer, I'm going to take out a red marker, no it's not. It's not part of this domain. And negative 2 is certainly not part of the range. This point does not belong as part of the function. So I can't draw a line through those points, and in fact I'm just going to erase this out, go backward here, because this line did not belong. Oop, I did erase a couple of the points I wanted in there. Okay, so this would be a correct picture of number 3. It's a correct graph of that function. I do not want to draw a line through it. One other quick problem we can go through together, and I think I'm done. Let's go to question number 10. And if you look at question number 10, the directions for this are to write a rule for the function represented by the graph. Identify the domain and the range of the function. So if I look at number 10, the easiest thing to do first might be for me to quickly make a table. I'm going to quickly make a nice table here, and then we can fill in our table with the points we see on the graph. So if I'm looking closely here at number 10, you can see at the point 0, 0, can you see a point on number 10 at 0, 0, a blue point? And I think you do. The next point I see is 1, 1. You go over 1 and up 1, that point is on the graph. 2, 2 is on this graph. So is 3, 3. I see 4, 4. I see 5, 5. And I see 6, 6. So they're asking me to do 3 things. Write a rule, identify the domain, and the range of the function. Well, I'm going to get the domain and range first. I think that's pretty easy. Here's my domain right here. These values are my domain. So 0, 1, 2, 3, 4, 5, and 6 are the domain of question 10. The range of question 10 is right here. 0, 1, 2, 3, 4, 5, and 6 are the range. Now they want me to write a rule. So let's think about this. Think about a box. Okay? When I put 0 in the box spit out 0. When I plugged 1 into the box, or I inputted 1, it outputted 1. When I inputted 2, it outputted 2. When I inputted 3, it outputted 3. You might already know the pattern. I can see it right now myself. Whatever I inputted in the box, that's what the box spit out. So, let's use better math teacher language here. Whatever I inputted into the box, that's what the box outputted. Or whatever I inputted into the function, I should say, is what the function outputted. So the rule here would be x equals y. The function is taking x, doing nothing to it, and spitting out y. So if I'm plugging in x, the box adds nothing to it, so I don't have to even put plug 0. I guess I could. If I wanted to, this would also be correct for that. X plus nothing equals y. Okay, I took x, did nothing to it, and it spit out y. So that would be the rule for that function. Okay, so I think that's probably enough to get you going here on this section today.